Look around you. The screen in front of your face, the chair you're sitting in, the memories of what you did yesterday, and the stars hanging in the sky above. What if none of it is actually real? The hypothesis treats the universe as a functioning piece of software, a literal program executed on a scale we can barely fathom. The suspicion that the physical world is a veil hiding a deeper truth has been debated for thousands of years. Ancient philosopher Plato imagined prisoners staring at shadows. René Descartes wondered if an all-powerful deceiver was fabricating human experience. In Hindu philosophy, the concept of Maya describes the material world as a mere appearance. For centuries, these ideas remained abstract philosophy. Today, the exponential growth of computing power has converted those questions into a set of observable, mathematical probabilities. This mathematical approach caught mainstream attention when entrepreneur Elon Musk laid out a devastatingly simple argument about the evolution of simulated environments. Consider the baseline. Just decades ago, the peak of human computing was a game of Pong, two moving rectangles and a dot. Today, we render massive, hyper-realistic virtual environments populated by millions of simultaneous users. Now, project that exact rate of technological advancement forward. Not 100 years, but thousands or millions of years into the future. If human computing power continues on its current trajectory, creating simulated realities indistinguishable from the physical world is an absolute inevitability. And if it's inevitable for us, we have to ask how we know an older, more advanced civilization hasn't already done it to us. This animated logic tree maps out our potential future. In 2003, philosopher Nick Bostrom formalized this exact problem, concluding that the survival of our species leads to one of three distinct possibilities. First, advanced civilizations might inevitably destroy themselves. Whether through nuclear war, artificial intelligence, or climate collapse, a species could simply go extinct long before reaching the capacity to build universe-sized computers. Second, a civilization survives, but they universally choose not to run universe simulations. Doing so might require too much energy, it might be considered deeply unethical, or they simply have zero interest in rendering their ancestors. The third possibility is that a civilization survives, and they inevitably create millions or even billions of simulated universes for research, historical preservation, or entertainment. If every advanced civilization runs countless ancestor simulations, the math creates a terrifying bottleneck. The number of simulated universes would dwarf the single physical base universe by billions to one. Under that logic, you have a 1 in a billion chance of currently inhabiting the original physical universe. The odds overwhelmingly dictate that we are already existing inside the code. Statistics can only go so far. To test this, researchers have looked at the physical universe itself to see if the fabric of space behaves like software. At the smallest observable scales, matter and energy do not flow in a continuous spectrum. They're delivered in tiny data packets called quanta. There is a smallest possible measurement of length, the Planck length. There is a strict, unbreakable limit to how fast anything can travel, the speed of light. These limits mirror the pixel grids and processing caps of modern software engines. Even more strangely, quantum mechanics dictates that certain particles do not have a definite state until they are directly measured or observed. In video game design, engines save computational power by leaving distant environments unrendered until the player actually looks at them. Most physicists quickly point out that these comparisons are flawed. They are human analogies applied to complex math. Modern physics perfectly explains quantum behavior and light speed limits without needing a programmer behind a keyboard. Yet the mathematical alignment between the laws of physics and the rules of software rendering keeps the theory incredibly difficult to completely dismiss. If reality is built on a digital grid, could it ever malfunction? Could a glitch ever bleed into our daily experience? People frequently point to things like déjà vu or the Mandela effect, where large groups misremember identical details, as proof of errors in the system. But these are well-documented psychological quirks of human memory, not literal tears in the fabric of space. Scientists looking for actual hard evidence of a digital grid, repeating errors or geometric limits in the vacuum of space, have found absolutely zero proof. Reality continues to function seamlessly, exactly as physics predicts. This leaves us with two options. Either the simulation is entirely flawless, or we have to confront the infinite regress. If we are simulated, who built the civilization that programmed us? And who programmed them? Let's step away from the probability of a simulation. Let's imagine you woke up tomorrow morning and discovered definitive proof that you are living inside a machine. What would that actually change? Would your happiest memories suddenly become less valuable? Would grief hurt less? Would human love lose its meaning just because it is generated by lines of code instead of biological carbon? The origin of the universe is secondary to the act of existing inside it. Whether a tree grows from physical soil or is rendered by a massive processor, you are here. The wind feels cold, the sun feels warm, and your choices are yours to make. Subjective experience is the only reality that truly matters.